So let's think about the ion concentrations. When we have a molecular substance like sugar and it dissolves in water, it separates into individual molecules, but the concentration of the molecules is the concentration that we would calculate, based on how many moles of the solid we added. With an ionic substance, though, ionic substance says dissociate or ionize. And so if we look at calcium chloride, CaCl2, when we put that into water, it ionizes and forms calcium ions and 2 chloride ions. So for every mole of calcium chloride that we put into the solution, we get 1 mole of calcium ions, but we get 2 moles of chloride ions. Do you see that? It's like if you had a dozen bicycles and you took them apart. You have a dozen frames, but you have 2 dozen wheels because each bike had 2 of them. So if we have a 1 molar calcium chloride solution, it's actually 2 molar in chloride ions. So the concentration of the individual ions can be approximated from the overall concentration. Most of these are actually equilibria, and so we can approximate the concentration, but we don't necessarily know super accurately. And in Chem 1B is where you learn how to do calculations like that. Let's do an example. Calcium chloride, 0.75 molar calcium chloride. Let's determine the molar concentrations of calcium ion and chloride ion in that solution. So 0.75, capital M means moles per liter. Moles of what? Moles of solute, right? Moles of calcium chloride. So you can just kind of think some of these through, but I'd rather show you how to, kind of prove it mathematically. If we want to know the number of moles of calcium ion per liter, then we're going to have to consider how many moles of calcium ions there are for every mole of calcium chloride. And this doesn't require an equation. You look at the chemical formula. CaCl2, there's 1 calcium. So there's 1 calcium for every 1 mole, and this ends up being the same. And you might say, well, that was dumb. Yeah, well, maybe it is dumb. But it's right. If the compound only has 1 atom of that element in it, then the concentrations are the same. But they're not the same for the chloride. 0.75 moles of calcium chloride per liter. That's just our concentration. Now let's see how many moles of chloride ions. Well, in 1 mole of calcium chloride, how many chlorides are there? There's 2. So this ends up being 1.5, that's a bad period, 1.5 moles of chloride ions per liter. Because the units are canceling. Moles of calcium chloride cancel moles of calcium chloride. Now we're talking about the molarity, the concentration of chloride ions in the solution. And in the top one, this also cancels out. This sort of a calculation is not that important. Okay, if you're trying to get an A, you should definitely get this. If you're just trying to get through, focus on the previous calculations we did and just kind of skip over this one and you'll be okay. So this is good to know, but it's not essential.